Hey guys, I hope that you're having a great day or good morning or good evening. My name is I play 4K, aka I play AK, aka I play 16K, or UHD King. UHD King, I with the 1. So today I'm going to show you Middle Earth's Shadow of Murder running on 16K resolution rendered in real time, which is 133 megapixels, downscaled then in 8K resolution on a single Titan RTX video card Turing GPU architecture that is equipped with 24 GB of VRAM and very old school enterprise CPU Xeon E5-2697 V2 from 2014. It's going to be a great video. I'm going to show you 16K resolution rendered in real time. This video will be around 1 hour. I'm going to discuss with you all kind of different presets. This game is still looking amazing when you're playing 8K resolution and above. And today we're gonna play 16K resolution, and trust me, there is a big difference between 8K resolution native and 16K resolution DSR to 8K resolution native downscale. You can see the difference on your 8K resolution TV. So grab yourself a self drink. It's going to be a long video. Before I'm going to get into the game, let me go ahead and introduce you what kind of system I'm using today in about 3-5 minutes. We're gonna jump into the game in about 3 minutes. So on the background, this is my system. Sorry about that. It was taken with my iPhone, and 400% zoom. And right now my desktop set to 16K resolution. Keep in mind that I'm not going to edit this video. I'm coming in real time as we go, so this video will be unedited. However, I'm going to compress this video with the FFmpeg++ freeware application, video editing, video converter application that I'm developing currently, probably using Java language right now, and it's going to be a freeware, guys. And what I find out right now, I'm using the NVIDIA Shadowplay hacked that recording actually in 8K resolution native instead of 4K resolution. It was hacked through the system ramp debugging tool, so I changed the values 8K resolution to 16K resolution. Sorry about that. This is the Shadowplay. I changed the 4K resolution to 8K resolution, and it's working. It's not upscaling. It's beautiful. I did the frames, compare them. It's real 8K resolution capture with NVIDIA. Not sure why they hiding from us. Why Jensen Huang, NVIDIA CEO and founder, hiding it from us, but it is what it is. So over here on the logo, I play 4K.com. As you can see, my logo, my old nickname, right now it's UHD King, but anyways, you can find me on all 4 nicknames. I play 4K, I play 8K, I play 16K, because I was the first gentleman who introduced to you 16K resolution back in 2016 on my 4 Titan X Maxwell GPU architecture. But today we're going to run on a single Titan RTX Turing GPU architecture that is as powerful as, I believe, based on this particular benchmark, as 3 Titan X Maxwell GPU architecture. And each Titan X Maxwell GPU architecture is equal to GTX 1070. Only Titan X Maxwell GPU architecture featuring more RAM. It's featuring up to 12 GB of VRAM instead of 8 GB of VRAM on the GTX 1070. So pretty much 3 GTX 1070 in SLI as a single Titan RTX. So let me show you my background resolution real quick for those naysayers. I'm going to use again zoom tool. 400% zoom tool, it's 32K when you're running 16K resolution, and today I'm running exactly 16K resolution and my desktop as well. So it's 15,360 pixels by 8,640 pixels, or 133 megapixels, as again, or to be precise, 132.56 megapixels. Still a lot. It's amazing. It's rendering in real time, and it's capturing the whole deal right now with NVIDIA Shadowplay as again. So please add 3 FPS to the FPS counter to get my FPS without the recording. Okay, so I'm using the scale up to 100%. As you can see, Windows recommended 500%, but I'm using up to 100% just for those naysayers, just in case. so I'm going to use zoom tool a lot. Even an 8K resolution TV, you still need to use the zoom tool. So Microsoft did the right job, good job when recommending 500%, because 500% is going to be amazing, and you're going to see every single detail, every single font, letter when you're running 8K resolution native, especially like 8K resolution native TV. All right, so enough of that. Let me go actually 600%, a little bit larger than that, or 700%, 700%. So as you can see, this is the Titan RTX running completely right now idling. I'm going to show you one test idling, and then I'm going to show all kind of different presets. One Titan RTX video card will be overclocked. Titan RTX video card today running completely stock, even without the liquid metal thermal compound paste. This is my workstation, guys. This is not the gaming PC. And when I'm going to show you the gaming PC, Titan RTX on liquid metal with the i9-9900K overclock at 5.3 gigahertz, or two Titan RTXs in SLI will be presented during that videos, and also possibility 10,900K. Okay, so what we got here, guys? As you can see, at stock, pixel fill rate 169 gigapixels, textual fill rate 509 gigatexels, and bandwidth will be 672 gigabytes per second. Right now I'm going to overclock it, my Titan RTX, and these values will be increased by a lot actually, and but pretty much this software overclock gives you I'm going to go ahead and explain to you how much FPS is going to give you at all kind of different scenarios based on my experience. As again, I've been PC hardware enthusiast, PC overclocker since 1997 when I made my first 386 IBM computer. And then it was even without the co-processor, without the DX technology that was later introduced on 486. So I couldn't run Doom, I couldn't run Doom 2 on the 386. The only FPS shooter by ID software was available, Wolfenstein 3D, for me at 1997 to be able to play it on 386 computer. But during that time it was amazing. Anyways, so I'm using the Xeon E5-2697 V2 CPU that I picked up in 2020, very cheap, for $120, used like new from great reseller on eBay. It was a reseller with like 10,000 5 stars. This is what I'm advising in 2021. Or better probably pick up yourself an AMD CPU. It's going to be also cheap, a little bit more expensive than this CPU, but it's going to give you similar performance or even a hair faster. Keep that in mind. AMD, I'm talking about the AMD that was introduced to us in 2020, like Ryzen series. Okay, so I disabled 9 cores, and I disabled the hyper-threading technology, so I'm running the native or physical 3 cores, 3 threads physical without any virtual cores. This is how I believe the fastest possible scenario. So they're sharing 3 cores, sharing 30 megabytes of level 3rd cache on the CPU. And why I did that? Because the CPU is not overclockable. Even if I'm having right now it in a motherboard that is gaming motherboard from my computer from 2014, it's still not overclockable. You can through the multiplier, but you can only overclock it through the BCLK base frequency and base clock, and it's running completely stock at 100 megahertz, and I overclock it by 6 additional megahertz, and actually it gives us 200 megahertz boost per each core, no matter what the scenarios. And then the Xeon E5-2697 V2 has an any 2600 CPUs V2 Xeon E5s will have the scenarios where we can use the turbo boost, and at 4 cores it's going to use 33 multiplier, at 3 cores 34 multiplier, and at 2 cores 33, and no, 34 at 2 cores, and 35 at 1 core. Okay, but unfortunately 3 core 3 threads will be more than enough to run 16K resolution in this old school game. In newer games probably 4 core 4 threads, but the higher the resolution is, the less cores you need, but you're going to benefit if it's going to be as high as frequency as possible. So to get the turbo boost that automatically boosting the frequencies on this Intel CPU, but it's locked, it's not controlled by me, I need to lower the cores as well. So I'm boosting, when I'm running 12 core 24 threads, I'm running 3200 megahertz or 3.2 gigahertz per each core. And sometimes in the games it's boosting to 3.4, but anyways, not all the time. It's like for a couple seconds. But right now we're going to set exactly at 3500 megahertz, and sometimes, as you can see, it's boosting to 3600 megahertz, which is 3.6 gigahertz or 3.5 gigahertz completely. But you're going to see it's going to boost a lot of 3.6 gigahertz because it's not going to fully utilize, fully stress the 3-core 3 threads. So for this particular game, actually 2-core 2 threads will be good enough, but I decided to show you with 3-core 3 threads just to show you the difference when we're going to run the benchmark of in the game. So here we go. Motherboard, the old school gaming motherboard X79UD3 with the F20 bias. It doesn't run with any other bias lower than F20. This is the latest bias from Gigabyte, was released in March 19, 2014. 16 times PCI Express version 3.0, 32 gigabyte DDR3. Yes, DDR3, because this motherboard supports only DDR3. This DDR3 is 1866 megahertz, but unfortunately, when you're running particular CPU such as 2697 V2, 1400 megahertz is your maximum kind of semi-stable frequencies, but completely stable frequencies will be 1100 megahertz as I'm running right now. And I decided to run it with the lowest possible latency, CS latency on my DDR3, and it's running quad channel, which is 256 bit instead of 128 bit, which is dual channel. Hopefully, guys, this makes sense. Titan RTX, as you can see, running right now completely stock, 24 gigabytes of GDR6 by Samsung that we are going to utilize in 16K resolution almost fully, which is nice to see. It says the TU102-300 and it says the revision A1. This is a mistake pulled out by CPU-Z. It's going to be TU102-400. I know those two CPUs exact this thing because I removed the cover on both of them. This is how it benched. As you can see, the CPU-Z under the multi-threaded benchmark doesn't recognize that I'm using the 3 cores, so pretty much it's benching like I'm using, almost like I'm using 2-core 2 threads. So in this particular benchmark, it's not going to recognize. Look like Windows 10 Pro, and Windows 10 Pro is kind of okay, but some of the applications have an issue when you have like 3 cores, 5 cores, 7 cores, 9 cores. You better have 2 cores, 4 cores, 6 cores, 8 cores, and you're not going to have any issues in 100% of the applications. But this is an unusual combination, and it's kind of recognized under the CPU-Z almost like 2-core 2 threads. So 2-core 2 threads multi-threaded performance the same, 353 score, and multi-thread performance 700 when I'm running the 2-core 2 threads. But right now is 715, so a little bit faster than that. And you can see multi-thread ratio almost 2x. So it's exactly, but as again, this is under the CPU-Z in the game, is going to be beautiful. Okay, and single thread performance on the i9-9900K overclock at 5.3 gigahertz, just 6 core 6 threads with the DDR4 3000 megahertz with the CL10 aggressive timing. My single thread performance score is 650, almost as multi-thread performance on 3-core 2 threads from the 2013 Xeon E5-2697 V2. So you can see how fast the 9 gen Intel i9, and 10 gen will be even a hair faster than that. So as again, it depends to the frequencies, of course. 10 gen needs to run 5.1 to match 5.3 9 gen per core. But anyways, so let me real quick go ahead and show you, but as again, don't pay too much attention. Maybe you want to pay attention to single thread performance because this is value most important in the PC gaming, not in the application, multi-threaded application, but PC gaming. But CPU-Z did for us the test, the single thread performance and multi-thread performance, so we can compare. So let me real quick go ahead and jump and show you all kind of different CPUs so you can compare. You can see the potential. Guys, this CPU 2697 V2 will be running on eBay in 2021 for $69.79, used like new on eBay. Buy from a seller that has at least 2005 stars, and you can also have two of them in Chinese motherboard and for like $120 and enjoy as workstation. As again, this is a workstation, and this workstation designed for video encoding and sometimes 3D rendering, and it's as fast as 6 core 6 threads at 5.3 gigahertz, a hair slower 2697 V2. Can you believe it? Of course you can. By showing the performance right now, you can kind of see where we at. But i9-9900K at 5.3 gigahertz is hair faster than this CPU with 12 cores, 24 threads, and the i9-9900K at 5.3 gigahertz running only 6 core 6 threads. So you can imagine how fast that CPU. And I'm talking about the multi-threaded benchmark. I'm talking about video encoding with all the 6 core 6 threads loaded at 100% versus 12 core 24 threads also loaded at 100%. But for $120, why not? And it's going to be even cheaper in 2021. So this is for those folks who's building old school system, use like new. This is the best idea when you're in PC gaming and PC hardware enthusiasts. You don't need to do like I do. Because I'm a YouTuber, I'm showing you the information. But for you, buy yourself the equipment, use like new, guys. But from a good seller with 30 days warranty, and trust the equipment for those 30 days, and you're going to be Gucci. If nothing will fail, you're going to be Gucci for at least 3-5 years in advance and save some money. Alright, so I'm going to increase actually I'm not going to do it right now. Let me go ahead and start the game. I showed you everything what I wanted to show you. So let's go ahead and start the game. We have a beautiful introduction. Everything was explained. Guys, I also software developer, graphics designer, 3D artist, but not of course since 1997, but I have at least 5 years per each. So I'm going to share great information with you. This is at the left top my system information. This is the maximum possible scenario on the font size. You cannot go larger under the MSI Afterburner in 2020. Keep that in mind. Maybe they're going to fix it. Maybe they're going to create a font as a vector. They're going to be scaled up to 32K resolution. But at 32K resolution, you're probably not going to see without the zoom tool the display information at the left top. But believe me or not, in Windows XP, Windows 10 Pro that I'm using right now. Sorry if I was saying Windows 7 or Windows XP. I'm not reading this information. I'm coming in real time and I'm multitasking with my brain at the same time. So Windows 10 Pro in 2020, guys, doesn't support everything above 16K resolution. Just want to let you know. So we're going to start completely stock idling Titan RTX, going to be controlled with the driver without any overclock, without any manipulation on the GPU or video RAM on the Titan RTX video card. And we're going to start 16K resolution, 100% scale. Okay, full screen. Guys, this is single Titan RTX, but this game supporting the two Titan RTXs and SLI, or it's supporting the SLI, keep that in mind. And this is going to be our preset. So I'm going to show you the way I'm going to play it if I would play this game and enjoy with the 16K resolution, DSR downscale to 8K resolution. This is exactly how I would play it, and then we're going to do the preset. As I told you, this video is going to be like 1 hour, so we're going to go through all the presets. I'm going to show you everything, so you're going to receive all kind of information that you need to receive. Again, this Titan RTX, as you can see, has the 24,832 megabytes of the video RAM. But when we're going to 2400 megabyte to 2400 megabyte, 24,000 megabyte, a little bit above it, it's starting overloading the system RAM by a little bit. And when we're going to get to 24,300, it's going to already offloading some data through the video RAM into the system RAM. And system RAM DDR3 is very slow, like oh my god. And when this happens, when a little bit of data offloaded from VRAM into the system RAM, the FPS is almost okay, maybe drop by 5 or 3. just like with NVIDIA Shadowplay that I'm recording right now consumes 3 FPS. But when it's offloading like a lot, like 1 gig, 2 gigs, above 2 gigs of video RAM into the system RAM, the data to 2 gigs, then you're going to see your FPS going to go to 1-3 FPS. And why it happens, even if the GPU is capable to push it, because it's getting that information, pulling that information through the DDR3 into the DDR3 and all those processes cycle, and it's just so slow than versus the GDR6. And RTX 3090 with GDR6X will be even faster than that. But this is going to be another video for another topic. Today we're testing the Titan RTX. Nobody done it. This is a very unique video. This is the first video, guys. 16K resolution. Shadow of Murder. Okay. So this is how we're going to rock. This game has built-in benchmark, which is nice, and look how small my mouse cursor right here. Let's go ahead and bench it. Guys, you want to keep your eye at the left top corner. You want to keep your eye at the VRAM usage. Right now it's 24,346. So already, as you can see, my system RAM usage 12,164 megabytes. So I believe we already offloaded about maybe 600-800 megabytes automatically into the system RAM, and this is done through the Windows 10 operating system and DirectX 11 API. Just don't want to overload the video card, and it sees that we getting to the limit of our VRAM, so it's automatically going to store already some data and try to escape the overloading of the VRAM while storing some data into the system RAM, guys. Hopefully this makes sense. I already recorded some great videos in 16K resolution, so that's probably, I already recorded like 3 videos: Batman Arkham Asylum in 16K resolution, and this setup, Batman Arkham City, and Batman Arkham not the night but the before the night. So my voice will be a little bit squeaky, but this is not about me, this is not about my voice, this is about the performance and sharing the valuable multi-angle information for you. It's not the copycats, as you can see over here. Look at this. Wow, 6 FPS. As again, you gotta add at least a 2-3 FPS to the FPS counter. So actually it was running like 8-9 FPS average without the shadow play recording, but with the shadow play recording, this is the results. Okay, so right now what I'm gonna do, I'm going to go and get, oops, not there. Hopefully it's not going to crash on us. This game doesn't like it. 16K resolution jumping inside and out into the desktop. I probably should do this photo on my iPhone, go through my artificial intelligence resizing, and it's going to clean all of this nonsense and noise. But this is 16K resolution 100%, exactly 133 megapixels. An iPhone is not 133 megapixels. I believe it's like 12 megapixels on the iPhone XR. It was taken with the iPhone XR. So idling. So keep your eye at these settings, as I told you. Right now I'm going to use my preset. Keep in mind that Titan RTX overclocking video tutorial is coming over the iPlay4K.com YouTube channel or over the UHDKing.com YouTube channel, UHD King I with the 1, number 1. Okay, so you can hear the noise even in the big room or small room. The Titan RTX is still noisy. It's not as noisy as single Titan X Maxwell GPU architecture. Certainly it's like 2 times less noise, but it's almost as noisy as Titan XP, maybe less by 10%, 10-15%, but it's still noisy. So as you can see, 179.5 gigapixels, texture fill rate 538 gigatexels, and bandwidth 768 gigabytes per second. Wow, almost like 60 gigabytes per second, almost like GDR6X actually from stock on RTX 3090. Anyways, let's go ahead and have a look now, shall we? Let me get back to the game. Oops. Nope. Here we go. Kind of sitting from the distance, trying not to pick up with my professional mics the fan noise. Alright, so this is what it is. Average 6.70. Let's go ahead and have a look. Idling versus the maximum stable overclock on air for almost any user. Let's go ahead and have a look how it's going to do. It's going to be better or not. And while I'm going to do that, I'm going to explain my algorithm how to calculate what will be your performance from the software overclock. As again, let me real quick go ahead and search for those naysayers. This is what's up. And apply, of course, yes. Okay. I'm not sure why it's flickering now. Maybe I should leave this window. It didn't flicker before. Sometimes full screen will be flickering on 16K resolution. Some shaders. Shaders as a textures in the game. Advanced options as again, just like you saw it. Let me real quick go ahead and start the benchmark. Oops. What happened? Yeah, I probably should reopen. This game doesn't like to jump in and jump out from the full screen to the desktop. So now it's probably going to be alright without the flickering. Alright. So let's go ahead and run the benchmark, and I'm going to, during the benchmark, explain to you my algorithm. It's a little bit flickering, a little bit. It didn't do it when I was running idling. I'm not sure why it's doing that. So my algorithm, guys, when you're running average FPS without the overclocking, 30 FPS, your boost through the software overclocking through MSI Afterburner will be 2-3 FPS maximum. When you're running 60-50 FPS average, your boost will be 3-5 FPS average through the software overclock. When you're running 90-100 FPS without the overclocking, your FPS boost through the overclocking will be additionally 7-10 FPS. Hopefully this makes sense. I tested, it works like that. This algorithm works like that and mathematically correct after the actual benchmarks and comparison with 95% of the games. Look how beautiful it looks at 16K resolution. We improved by 1 FPS at least, but as again, we are not running 30 FPS average without overclocking, so probably going to be improved by 1, maybe maximum 2 FPS. With the 12 core 24 threads, my FPS will be even lower than that. So I increased by about 1 FPS extra when I'm running below 30 FPS with the 400 MHz overclock on each core. So additional 1 FPS just CPU overclock, and from 12 core 24 threads, just 3 core 3 threads, and additional through the software overclock. So we improved by 2 FPS actually. That's great. So software overclocking, guys, is great, as you can see. It brings the potential, it brings that FPS, and pretty much 3 FPS takes the shadow play while recording the particular game, Shadow of Murder, and pretty much you're going to compensate the rest just through the software overclocking on your video card and GPU and video RAM. Why not, right? So what I'm gonna do now, so we tested that, so this is how I would play it, and of course it was 16K resolution, 100% scaling. Now I'm going to go ahead and use the presets. So we're gonna start with the very low, and we're going to increase. Lowest. Here we go. This is how, not the ultra. Ultra will be the last, so stick around. Guys, don't forget to smash that like button. A lot of time, money, energy was invested, and I'm just wasting my time and my money while sharing the experience with you. But I believe that some people will have this information as very valuable information, especially PC hardware enthusiasts, PC overclockers. So don't forget to smash that like button, subscribe, share it with the friends. I'm providing you the real information. There is no copycats, there is no misinformation over here. Everything what you can see, it's unique content, unique videos, and on top of it, it's beautiful. Okay, it's flickering again. I'm not sure why it does it. It didn't do it for me when I didn't record with the shadow play. Maybe just a shadow play on top of it. It just takes a lot of performance. But lowest 16K resolution. Let me out and get in again. Maybe it's going to fix that. Here we go. It should. As again, shadow play is recording in 8K resolution at 60 FPS, which is amazing as well. Alright, let me go ahead and start the benchmark. So all kind of different presets. I know a lot of folks appreciate that, especially my subscribers. So this is, guys, for you. Don't forget to smash that like button. As again, positive comments, guys. And this is not one of those YouTube channels that showing you some benchmarks when they're running GTX 1080 video card, but they name it all kind of different video cards. They just faking it, misinformation, providing you the misinformation, and I just hate those guys. And this channel is not about that. This channel is about the truth and about the future. Right now you're watching 5 years in advance. You're watching the future, and it's, the purpose of this, for people who's going to ask the purpose, so we can compare this information and we can see the video card progress, the system progress, the CPU progress, all kind of different hardware progress, and we can compare. From time to time, I ran this in 8K resolution and 10K resolution with 4 Titan X Maxwell GPU architecture with 2 GTX 1080 Ti video cards, and now it's great to compare it with the Titan RTX single video card, and I will try to go ahead and run it for you, Titan RTX and SLI on this workstation, as well as I'm going to run on my gaming station. So this is just a workstation. I will try the SLI on this workstation. Okay, so you don't need the top of the end CPU when you playing 8K resolution and above, by the way. So you saw the FPS, guys. So now we're going to go ahead and it was so quick. Hopefully go ahead and rewind if you if it was so quick, but it was the lowest. Now I'm going to go ahead and switch to low preset. Let's go ahead and try that. Okay, it didn't flickering at all at low. As again, for naysayers, resolution is resolution, and I'm not going to add in this video at all. Only we compress it. And through the FFmpeg++ freeware application that I'm developing right now in Java, it's going to be based on the FFmpeg open source library. What it's going to do, it's going to pretty much take the video, reduce the size, the file size by 2, but it's going to keep the same quality, and something that I come out with. And in the future I will also add the artificial intelligence video manipulation, and I'm going to include into the FFmpeg++ software that I'm developing. It's going to be a great software for you to use. Hopefully I'm going to finish it. I'm developing on my expenses and my knowledge, my experience. Hopefully I'm going to finish it, because right now, as you can see, I'm busy with a lot of stuff. So support me, guys, with everything what you see over the iPlay4k.com YouTube channel, or over the iPlay16k.com, as you can see, completely makes sense, or over the UHDking.com. I as number 1. So average FPS 14 FPS, not bad. Look at this, we're increasing 14 FPS, 16K resolution at low, not bad. That means that 2 Titan RTXs and SLI, even on this workstation, will show us around 28, maybe 30 FPS when overclock, but 25 for sure. So 25, almost like a playable experience. Right now it's not the playable experience, I know, but it's bingeable. You cannot say it's not, because it is. Guys, I'm still learning my mics. I have 2 professional Rode mics. Hopefully you're enjoying that. I decided to go ahead and use 2 professional, so it's going to be nice, and voice going to be not so low, not so high. Hopefully it's nice quality. So medium preset. Alright, coming from the first YouTuber that showed you 16K resolution back in 2016. Let's go ahead and run the benchmark. Medium preset. Okay. Guys, when I was running 4 Titan X Maxwell GPU architecture in 8K resolution, when the camera was rolling, I saw the objects was pop up, and you can see this kind of pop up better quality. What is doing that is because the VRAM wasn't fast enough on Titan X Maxwell GPU architecture, but on Titan RTX for this particular game at 16K resolution it's fast enough, as you can see our GDR6 by Samsung. Of course, the GPU doesn't have enough processing power to do a playable performance, but as again, we understand that this is the first time you can run Shadow of Murder Millers at 16K resolution. Of course, I forgot to smash that apply button. Let me go ahead and go back and smash that apply button. I'm apologizing for that. I'm gonna smash that apply button. Actually, I didn't forget to smash that apply button. It shows us actually lower FPS, but let me go ahead and it was before it was on low, it was 14, and right now it was like 11, but still not bad. Okay, let's go ahead and try it again. Let's see what's going to happen. Somehow when I'm recording with the shadow play, it's flickering sometimes. I'm not sure why, if you're gonna see it on the video or not, but when I'm not recording with NVIDIA shadow play, it doesn't do that. I'm recording right now with NVIDIA shadow play, and probably this is what I'm gonna do in the future, because my Chinese 8K resolution recorder, external professional recorder, something happened to it, but I have 3 years warranty, and I just send it back to them, and they're going to send it back to me in maybe 2 weeks, and but then I will record when the FPS will be so low in some particular games throughout the benchmarks. Probably I'm going to use that recorder, but something went bad with that recorder. It's overheated, and it's just 8K resolution in real time. Takes a lot of guys hardware, expensive hardware, and should be performed well, and it's kind of getting hot. 11 FPS, wow. So I did smash that apply button. Even if I don't have to, it's automatically did it for us. Let's go ahead and do the high now. And of course, I showed you guys the preset that I would play it. Maybe in the end I'm going to show you the playable preset, because that preset probably wasn't too much playable for a lot of folks, but I will try to show you the playable preset. So this is the high preset right now, 16K. Let's go ahead and have a look. As again guys, unfortunately I cannot increase the font size. I would probably increase it by a little bit more, by about 25%, so people can see it even on the phones and the iPads, but it's not increasable on the through the MS Afterburner in 2020. I'm going to show it to you. This is the maximum possible in 16K resolution, the size of the font. 9 FPS, but beautiful. Everything is such a beautiful. Even the 3D mesh is looking like they have the higher polygon count, but they do not. It's just illusion. But why it is like that? Because the texture that applied on that 3D mesh, pretty much showing us every single pixel on that texture. Because as you can see, the objects, 3D meshes, 3D models, whatever you want to call them, so small. So the texture that you apply on that at 1080p or even 4K resolution, not even showing 100%, even if the texture is 1080p at 4K resolution. Because this type of guy right now, as you can see at the left top, was like what? Like quarter of the screen, even less than quarter of the screen. So even 1080p resolution texture, when you're running 4K resolution completely, your game running at 4K resolution is not going to show all 1080p pixels. Hopefully guys this makes sense. But 16K resolution, we're showing all pixels. We're not stretching them, we're just showing them exactly as it is. We're stretching them when we're running low resolution because we're decreasing some details. And when we're running 16K resolution, we show all kind of details, and if there is some extra space that we can fit extra pixels, maybe we upscaling that pixels. Okay, so that was at high. Now I'm going to show you very high. But this is a serious settings, guys. 16K resolution. This is the first time. I know I'm very impressed. I'm not going to show you my emotions, but I was ultimately impressed when I saw that this game is runnable at 16K resolution. What happened here right now? At very high? Okay, it just was thinking about something, and I believe it was thinking like, oh my god, dude, you overload your VRAM, as you can see at the left top, and the game probably going to crash, because yep, it did, because VRAM load was like 10 gigabytes, and it should be way above that. It should be way above 20,000 megabytes, above 20 gigabytes, and it crashed the game. We're going to reboot the game, restart the game. Very high. So pretty much the what happened here, let me explain to you as a software developer point of view. So the collector couldn't clean fast enough of the VRAM from the high preset, and it overloaded our VRAM, and it's completely overloaded that limit that can NVIDIA driver can store into the system RAM, completely also overloaded, so the whole game is crashed in the DirectX 11 API. And this is, guys, DirectX 11 API, and I'm going to show you a lot of games is runnable, the old school games at 16K resolution DSR, well, downscale to 8K native, which is doesn't matter, guys, if it downscale to 8K native or not, it's still going to be 16K resolution pixels rendered in real time. So when the 16K resolution monitors will be available, pretty much you're going to receive the same performance in terms of the FPS and same data at the left top, plus minus maybe 1-2 FPS, but it's going to be the same. NVIDIA DSR doing the right job, the good job. No, it's still doing something. It's not moving, guys. It's very high. As you can see, VRAM load is 20,686 megabytes, but my system RAM load went from 12 gigabytes to 13,000 megabytes. Means that we are overloading some system RAM right now. Who knows? Maybe it's not allowed to have something like that, and we are already overloaded and it's about to crash. There's a possibility. Let me try to go back to the desktop and try to go back to the game. Maybe it's going to help, but I think it's going to crash. Yep, it did crash. So very high is overloading 24 gigabyte of our Titan RTX completely. It's not even going to ask us. It's just going to go ahead and overload it, and it's overloading while it's crashing. You would say, well, we still have system RAM as 32 gigs. Yeah, we do, but while it's crashing, oh, look at that Steam window at the right bottom corner. You saw how small it is? This means 16K resolution business. So you will say, yeah, we still have system RAM 32 gigs. We still have like what, like almost 18 gigs to go, but NVIDIA driver and Windows operating system, and there is a possibility. I'm not sure if DirectX 11 API is kind of managing it, maybe through the internal processes that it's not available for the developer, but for the developer as a game developer, but for the Microsoft is available. But I don't think it's DirectX 11 API. I think it's NVIDIA driver and Windows operating system is managing that, and it probably has some limit how much data it can store into the system RAM. And yeah, as you can see right now, it's 19 gigabytes, it was 20 gigabytes, so it's kind of guessing, and it's not guessing right, and it's going to crash again. So it's overloading, and overloading. Maybe we're still going to boot it. See like how slow it is, and it's probably like 1 FPS, 1-2 FPS, like I told you at the beginning as my algorithm. And why it's doing that, because a lot of data loaded into system RAM. Look at this, 14,000 megabytes of the system RAM right there, guys. 14,000 megabytes, and it's still thinking. It didn't load the whole menu 3D character yet. You just saw 14,000 megabytes and then 13,000 megabytes, again 14,000 megabytes, probably like 16,000 or 17,000 megabytes, and it's probably overloaded the limit of the system RAM as well. I think the limit of the system RAM is 3 gigs or 4 gigs as maximum. After that point, everything is crashing. This is at least was the scenario for the RTX 2080 Ti. I believe 4 gigs or 5 gigs, and everything after that point it was crashing, or was showing like 1-2 FPS like it's doing right now. So very high is not possible, and ultra will not be possible. So that's it, guys. I showed you everything what you need to know, I guess, and it just completely, look at this, it just hanged the system, and it's like, dude, you're running something unbelievable. Even Microsoft, like, who is this UHD king? Who is this guy? Because they probably see all those people receiving some statistics, and they're like, look at this guy. This guy running 16K resolution games like crazy, and the FPS, because they're collecting through the Windows operating system. If you're going to sign up, send some reports to Microsoft, they're collecting this information. Even if you're not going to check mark to send some reports to them, I'm pretty sure this company is collecting some information on you as well. Alright guys, that's pretty much it. And thank you so much for watching. I'm going to record the Shadow of Mordor in 8K resolution on this system as well, and hopefully 8K and 16K resolution on this desktop workstation system, which is Morozilla rendering firm version 1.1. Version 1.0, my first workstation server system for rendering video and 3D. Probably I'm going to show you 2 Titan RTXs in SLI, and then I'm pretty sure I'm going to show you the my gaming system, i9-9900K with 2 Titan RTXs in SLI, and as well I'm going to show you guys the probably 10900K or something like that. And then of course RTX 3080 in SLI, no, of course not, because it doesn't have the 24 gigs. And I'm showing you all this Ultra HD, top of the flagship, whatever, 5-7 years in advance, Back to the Future. So I needed 24 gigs. So probably it's going to be RTX 3090 video card test and RTX 3090 in SLI, and maybe the Ampere Titan, if it ever will be released. If not, then this is the last Titan alive, guys, Titan RTX. Thank you so much for watching. Have a great day. Don't forget to smash that like button, subscribe, and I will see you guys in the next videos. Positive comments. Till the next time.